Hello again. In this video, I'll be presenting selected solutions of the factoring problems that I hope you've been working on. Okay, let's start with this first problem, which is a binomial expression. And right away, and I'm hoping by this point you're seeing a common factor that you can take out of both terms right away. I see 15 and 16. They have a common factor of 15. Okay, so here we go, 15. There's a w cubed and a w squared. My greatest common factor for those terms is w squared. Now I'm ready to go. What times 15w squared gives me 15w cubed? Well, that's just w, minus what term times 15w squared gives me 60w squared? That's just 4. And that's it. We're done. You can't factor that into anything simpler than that. Next problem. Number 4. Okay, we've got a binomial expression again, and I'm going to be looking for a greatest common factor once more. Let's go step by step. Numbers. Looks like we've got a 2. Powers of x. X cubed is as high as I can go. Powers of y. Y to the 4th is as high as I can go. So I'm ready. What times 2x cubed y to the 4th gives me this? Well, it looks like I need an 8x to the 4th. What times 2x cubed y to the 4th gives me 2x cubed y to the 6th? Well, it looks like I'm only going to need a y term. That's going to be plus y squared. And that's it. It looks like there might be something we could do with this, but there really isn't. So this is as simple as factoring as we can do. That's as far as we can go. So we're done with this problem. Next up is problem number 7, which is a binomial. And you might think, well, there's nothing I can take out of both. There's no greatest common factor. That's true. But this is a special binomial because this term is a perfect square and this term is a perfect square. That's what we call the difference of squares. So when we factor it, it's going to look like this, 2 binomial expressions multiplied. And ask myself, well, what times itself gives me 4x squared? That's just 2x, so I put those here. What times itself gives me 81? Well, it's the square root of 81, which is 9. So I put a 9 here and a 9 here. And then I just put a plus here and a minus here. And if you want to go on the wild side, you can put a minus sign here and a plus sign there. Impress all your friends. Next problem. Okay, here we've got a trinomial. And I'm looking at this and I'm realizing, okay, each of them has a factor of 2 in common. I think that's the greatest common factor I can take out. So here we go. I'm going to take out a 2. What's left? Y squared plus 5y minus 36. Now our next step, if you remember, is what 2 numbers multiply to give me this number, minus 36, which then add to give me 5? Well, some of you might jump right to the answer. It's okay if you can't see it right away. Let's list the factors and the integer factors of 36. 1, 36, 2, 18, 3, 12, there's a lot of them, 4 and 9, 6 and 6. There we go. Now remember that one of these numbers in each pair, and you can write them all out if you want. I just wrote 1 and 36. You can write 1 and minus 36 and minus 1 and 36. You're going to make a pretty long list. It's going to have 10 entries in it. But some people might find that easier. They can just go through one step by step. I prefer to just write out the pairs. And then because this is negative, these have to multiply to give me negative 36. It means that one of these numbers has to be negative. And remember that they need to add to give me 5. Well, 1 and 36 is not going to do it. 2 and 18, not going to do it. 3 and 12, not going to do it. 4 and 9, I think that's our answer because 9 plus minus 4 gives me 5. So the answer is y. We need those to multiply to y squared. And then I just put the two numbers I just mentioned, plus 9 and minus 4. Trinomials like this are a little bit more involved, especially when you have a constant coefficient here, which has lots of factors. You just need to go through them all. Once you've done this often enough, you might be able to do this part in your head. But if not, if you're making mistakes, why not just be careful and list all of them? And then you just have to go through them one by one, cross them out if they don't work. Next problem. Okay, this one's a little bit scary looking. Let's not panic. One, I noticed that there's a common factor here. I see y squared everywhere, so we're going to factor that out. I also see each one of these numbers can be divided by 7. So I'm going to factor out 7y squared. That's our greatest common factor. What's left? I have 2x squared plus 7x minus 4. Okay, I covered up that y squared there, but I factored out a y squared, and this is what's left. Okay. And here's an example of where we have to use what I call the British method. First, we multiply the 2 and the minus 4, and that's going to give us minus 8. Now we come up, just like we did before, we come up with factor pairs. So 1 and 8. And again, you can list minus 1 and 8, right? Or 1 and minus 8. It's up to you. We also have 2 and 4. Okay, that's not so bad. Those are the only two pairs. Which of these pairs could possibly add or subtract to give me 7? Well, 8 minus 1, I think that's going to do it for us. Okay, now in the British method, we're basically going to rewrite that middle term using those two numbers I just mentioned. Notice that 8x minus x equals 7x. And then I look at these and I think, let's take the first pair and the second pair and factor out what's in common, which in this case is 2x, x plus 4, minus 1, x plus 4. If you do it right, you'll have the same thing that you factored out. Now I'm done. 2x minus 1, x plus 4. And you've factored the original problem. Good for you.